Hello data enthusiast. If you observe closely, nothing in this world is truly random. Everything follows a pattern, except maybe my sleep schedule, which is completely chaotic mess. But let's focus on something that makes sense. Take your favorite cafe for example. You don't just see them selling 10 coffees one day and then 1000 the next, unless their secret ingredient is magic. There is a certain consistency, but that consistency depends on external factors, like the weather. When it is cold, we want coffee. When it is hot, we want something that won't make us feel like a boiling potato, like fresh juice. There is a lovely relationship between the temperature and coffee sale. And guess what? Regression is simply figuring out that relationship. We are not trying to solve family dramas here, just finding mathematical relationship between the variables. Welcome to today's session where we dive into the magical world of linear regression. Previously, you learnt about fitting the best model using hypothesis and improving it theoretically. But today, let's bring theory to life. Sounds fun, right? So what is linear regression? And why it is famous as an influencer with million followers? Well, linear regression is like trying to draw the best fitting straight line through a bunch of scattered points. It is not an art class, so we are not just randomly doodling here. This is the line of best fit, the one that minimizes error, a fancy way of saying we are trying to be as accurate as possible without losing our sanity. But wait. Drawing a straight line is easy, right? You just grab a ruler and mark the line. Well, not so fast. In regression, we don't just draw a line, we calculate its equation mathematically. Don't panic yet. We will take baby steps. I promise there will be no scary calculus nightmares today. So we know regression is about finding patterns. The general equation of regression is y is equal to f of x. Basically, y depends on x, like how my mood depends on how much sleep I got. If x changes, y changes accordingly. Simple. Now, for our beloved equation for linear regression, y is equal to mx plus c, where m, the slope, how steep the line is. Think of it as the spiciness level of the relationship. C, y-intercept, where the line crosses the y-axis, that is where it all begins. Linear regression is everywhere, but we just don't pay attention. Let's go through some examples that scream, I am a linear regression problem, but in a socially acceptable way. First example, house price. Want to know how much a house cost? Easy, just check the area. Bigger the house, bigger the price tag, unless it is haunted. Of course, other things matter too, like location, material, and whether it comes with noisy neighbor included. But generally, bigger house is bigger price. Linear regression at work. Second example, salary predictions. How much will I earn in the future? Good question. If we ignore exceptional cases, like that one friend who started a YouTube channel and got rich overnight, salaries generally increase with the years of experience. More experience is more salary. If not, it's time to change job. Next example, health and fitness. How many calories do I burn if I run for 30 minutes? The answer is simple. More running, more calories burned. Plot the data and you will likely see a straight line pattern. Run more, burn more. Again, linear regression. Next example, student scores. If you don't study at all, your exam results might be so bad that even linear regression won't save you. On the flip side, more study time usually means higher scores. Unless you are studying memes instead of mathematics. Again, a linear pattern appears. See, linear regression isn't just some scary algorithm, it's real life. Next time you notice patterns around you, know that there is math working behind the scenes. Alright, now we have a problem. Linear regression problem. But don't panic. Problems exist so we can flex our brain muscles and solve them. So grab your snacks, fuel up that brain, and let's crack one of the universe's simplest yet coolest mysteries, the equation of a straight line. Meet the superstar equation y is equal to mx plus c. This equation is famous, more famous than any reality show star. But what do its co-stars m and c actually do? Let's investigate. M, slope. This guy decides how tilty the line is. Will it gently climb like a turtle on a hill, or take a nosedive like a stock market crash? C, intercept. This is where the line decides to start its journey on the y-axis. Think of it as the GPS starting point of the line. But we all know theory is like a salad. Good for you, but hard to enjoy. So let's spice things up with some experiments. Let's play mess with the equation. Our test subject, y is equal to x plus 1. Comparing it with y is equal to mx plus c, we see our superstars. M is equal to 1, c is equal to 1. No complaints? Good. Let's throw some numbers in and see what happens. When x is equal to 0, y is equal to 1. When x is equal to 1, y is equal to 2. When x is equal to 2, y is equal to 3. The result? A polite, well-mannered line climbing uphill steadily. But we are not here for politeness. We want chaos. Let's tweak the parameters. First, let's mess with c, the up and down mover. Increase c to 2. The equation is now y is equal to x plus 2. Oh, the line gets a promotion and moves up, but its attitude, tilt, remains the same. Drop c to 0. The equation becomes y is equal to x. Now the line steps down and starts from the origin, just like someone losing a job and moving back home. Moral of the story: C, shift the line up or down, like an elevator. Now let's mess with M, the tilt master. Back to y is equal to x plus 1, but let's crank up the spice. Set M is equal to 2. Now we have y is equal to 2x plus 1. The line steadily turns ambitious and gets steeper, like someone trying to sprint up a mountain. Set M is equal to 0. Now y is equal to 1. What just happened? The line stopped caring, laid down horizontally and started sunbathing on the x-axis. Set M is equal to -1. The line goes a backflip and tilts downward, as if it just realized it forgot to submit an assignment on time. Lesson learned? M controls how much drama the line brings, flat, climbing or diving. Now let's talk about regression like fancy data scientists. In linear regression, we refuse to use simple words. So M, slope, is now weight, W, because we like sounding smart. C, intercept, is now called bias, B. But don't worry, their job descriptions remains the same. Weight W, the drama factor. Think of weights as the spice in your curry. A little bit enhances the flavor. Too much sets your mouth on fire. If W is small, X barely matters, like whispering in a rock concert. If W is equal to 0, X has zero influence on Y. You can send X $1 million text, Y won't care. If W is large, even a tiny movement on X sends Y flying off to the moon. Summary: W decides how much impact X has on Y. Now bias B. Bias gives the model a head start. Think of salary predictions. Zero experience doesn't mean zero salary, right? That is bias at work. Positive bias. It gives Y a boost, like an unfair head start in a race. Negative bias. It pulls Y down. Bias is the sneaky behind-the-scene force that shifts the Y's starting point. So now you know linear regression isn't just some boring math. It is a way of playing detective with numbers. All good? In machine learning, we continuously improve the model till we get the best model. But how do we decide if the model is the best or still needs to improve mathematically? That brings us to next concept, evaluating the ML models. We evaluate the students in the class, how well they have learned the concept using exams, and decide who is the student of the year, right? Similarly, we need a metric to decide the best model, some test. When you are baking cookies, it is easy to judge which one is the best. You taste a bite and say, "Oh, this is delicious." What about machine learning models? Well, unfortunately, you can't bite or taste them. So what do? We need a mathematical way to measure how good our model is. New hero of the story enters the plot, the cost function. Now we take an interval as our new hero just enters. In the next class, we discuss cost function in details.